folks, Mr. Dell here. We are looking at a problem that has to do with a formula, and we're going to manipulate that formula algebraically to solve for certain variables within that formula. So this is a problem that I'm taking from CPM's Integrated Math 2, and this is section 9.3.2, number 100, so 9-100. It says the area of a sector of a circle is given by this equation. So we know that this is the formula that finds the area of a sector, right? Just as a reminder, an area of a sector is if you knew the central angle, you would be able to find the area of all of that piece of pie. That's a sector, okay? So, and our theta is that central angle. R, of course, is the radius, okay? And then there's some numbers within there, pi and 360. So where it says where R is the radius and theta is the measure of degrees of the arc of the sector. Okay, so it wants us to solve for theta. So I'm going to take this, excuse me, take this formula, 360, and that's multiplied by pi times r squared. And I have to manipulate it algebraically to get what I want is theta all by itself. That's what I want. I want all of this formula now in terms of theta. So mathematically, what do we have? So I'm going to rewrite a little bit here. So remember, when you're multiplying, this is being multiplied by theta over 360. I can put that over 1, so I can see that it's really theta times pi times r squared, all divided by 360. So when you multiply fractions, you can just multiply straight across. So that gives me that opportunity to see that I just kind of multiply this time by 360, right? Because when you multiply 360, when it's being divided by 360, that cancels that out. That creates a 1. So on the other side as well, multiply by 360. Now I have a 360a over there. So let me rewrite our formula. 360a is equal to theta times pi times radius squared. So right there, now I just got to get my theta alone. So what I see is theta is being multiplied by pi and multiplied by r squared. So inverse of a multiplication is division. So I'm going to divide by the pi, right? That'll cause it to be a 1. Divide by r squared becomes a 1. And what you do to one side, you do to the other. So there's my answer. So I've got my theta now. I'll write it up a little higher. So I have my theta is equal to 360 times a, all divided by pi times radius squared. So there's my formula in terms of theta. So again, we're going to do the same thing, but now I want to solve for r. So let's look at this and see what algebra I need to do that. To save on steps here, I'm going to go right to where I multiplied, right? So I can rewrite this again, but I already did this one step, which was theta times pi times r squared on the first step the last time. So I want to do that again because that'll help me right away be able to multiply both sides by 360. So I do that because I'm trying to get r alone this time. This time I want r by itself, right? So I multiply by 360. So I have 360a is equal to theta times pi times r squared. So to get the r, at least at first here by itself, isolate the r term, right? It's an r squared. We'll tackle that, but the first thing I got to do is divide by that theta and pi. So I end up with r squared. When I divide, those become 1. R squared is equal to 360a divided by theta times pi. Okay, so last thing is I want r by itself. So I'm going to square root both sides because I have an r squared. So I've got to get r alone, right? When you think about the opposite of r squared is the square root, right? Because the square root of r squared is r. So we want r by itself. So I square root both sides. So there's my final answer now is 360a under the square root theta divided by theta pi. But because you square root within an equation, that means the answer is a positive or negative. So there's our final answer there. All right.